Hello, everyone, and welcome to another episode of Open Observability Talks. I'm your host, Dotan Horvitz, and here at Open Observability Talks, we talk about anything DevOps, observability, and open source. So may the open source be with you. I'd like to thank our sponsors, Logs.io, the cloud-native observability platform. Logs.io takes the best-of-breed open source projects such as Prometheus, OpenSearch, Jaeger, and offers them as a unified observability platform built for scale. For those joining the live stream on YouTube or Twitch, do feel free to share questions and comments on the live chat. That will definitely make our episode much more interesting. And with that, let's move straight on to today's episode. And today we have a special year-end episode where we can look back at 2023 and, more interestingly, explore what's coming next. And there's no better person for such a retrospective view than my guest, Kelsey Hightower. Hey, Kelsey.
Hey, happy to be here.
Yeah, thank you so much for joining me. And you're the man that doesn't need any titles and any introduction, but I'll let you give the opening words about yourself.
Well, I mean, hopefully people know me from someone that has been contributing in the Kubernetes community for a while. Maybe someone who before that was also doing a lot of the work that's behind the tools that we build. So have a lot of empathy for people who have racked the server and cut themselves on the metal edges of the unrolled steel. Have a lot of empathy for people that used to write shell scripts and then moved on to configuration management and then abandoned all of that in favor of some new approach. And I just think that's just been the job. It's a constant evolution, and we got to evolve just as fast as our systems do. And also someone who really loves the fact that open source is a thing, not only for free software, but the fact that the big ideas get serialized into something we can touch.
Yeah, that's definitely, and I should add that beyond all of that, really the empathy and the ability to get all of us as a community plugged into this, the new realms, the new domains, cloud native, Kubernetes, containerization, and so many others. That we all owe you to bring us together, to simplify notions, and really an inspiration. So thanks a lot for everything. And with that, I'd like to maybe start with looking back. We're recording that now, live streaming that, just a few weeks before the end of the year. So maybe how do you summarize 2023? What was that year for you?
Well, remember, I retired in 2023. And so for me, it was more about reaching some of the milestones and goals that I kind of set for myself since the beginning of my career for over 20, almost 25 years. And so I decided that now is the time to retire. But the one thing I realized is you never really retire, right? You may stop one form of work to do another form of work, even if it's as simple as cleaning your own home or something like that. And so for me, 2023 is this kind of reflection and then starting a new chapter. And so when I think about the technology side of it, I do think a lot of our projects are also on the same evolutionary journey, and they get to the point of maturity. And things usually need to change when they get mature. So you see people calling for like a LTS, a long-term edition of Kubernetes, this idea that we can just keep shipping new versions every 6 months and everyone's just going to upgrade. That's not really feasible, especially when it comes to low-level key infrastructure. People just want this thing to stabilize a bit. And we look at the CNCF landscape, more graduated projects, right? Like I think service mesh is getting so mature, it's getting a little boring. But it's also getting boring in the way that people are asking themselves, do they really need all of this? And another thing I think we're starting to see is that there's enough people with experience in production that, rightfully so, they're calling out the complexity. Do I really need this? Also in 2023, we saw a lot of people think about leaving the cloud. And some people would say that's a testimonial against cloud being something of a failed experience. I don't think that's the case. I do think the cloud native movement has allowed the cloud to scale down. So cloud APIs are no longer vendor specific locked in things. The S3 protocol, you can get that via MinIO and run it on-prem. Even VMware will give you a Kubernetes style API to manage containers and virtual machines. So I think this is a testimony of like all this hard work to normalize the cloud, create industry standards. We did a good job. They also scaled down. So leaving the cloud doesn't mean you have to leave cloud-like technologies. And I think that kind of just sums up 2023 for me, which is a sign of maturity, and that maturity has kind of outgrown the box it was planted in.
It's very interesting. And one thing that caught my eye, I actually brought it up with you earlier, and you said maybe this is worth its own discussion, is part of the maturity is the FinOps aspects, how to make it cost effective and to make sense, especially as more organizations actually work in a multi-cloud setup, so across different vendors, and each vendor speaks its own language and reports its own cloud bills in a different way. And usually people get this gigabyte size JSONs that they don't know how to ingest and how to then dissect, and they don't match any format that you can then, I don't know, throw into Prometheus and start using Grafana or whatnot to slice and dice it. And one of the things that I found interesting in the news section is actually that Focus, which is a new, I don't remember the initials, of FinOps open cost something specification by the FinOps Foundation, reached its first major release 1.0. And for me, a bigger news was that the fact that AWS, Amazon, joined the steering committee, where also Google and Microsoft have been there since the release 0.5. So now we have like the three major cloud providers now on the steering committee, and that sets it for actually becoming a real de facto language, specification, schema for reporting, and just removing all the difficulty and friction from understanding your bill and making us engineers make more out of the cloud. So I was wondering maybe if you have thoughts on the FinOps side of things, and maybe normalizing this aspect so that we can actually open up more fronts in making more out of the cloud.
Yeah, I mean, FinOps has like this special word, but I mean, finance has always been a part of anything, right? If you want to build a bridge, people say, well, how much taxes do we need to raise? And do we have to start a bond to pay for the bridge? Like, infrastructure tends to come with some financial component. I think a lot of people have been shielded away from the financial component. Like, think about it. Most people, when they join a company to do this type of work, they're not responsible for paying for anything, right? Like, someone's already bought the servers, someone's already paid for the Oracle license. You just come in and you operate it. So I do think a lot of people have kind of grown up in a system where you just operate it and you don't even know how much this stuff costs. You're like, hey, we should automate Oracle. It's like, hey, time out. If you were to automate Oracle and make it easy for people to just spin them up, we may have a huge licensing cost explosion. So, your strategy is devoid of cost. And then you learn the hard way when they do the audit and say, yay, you owe us $2 trillion now. And you're like, whoa, we were just trying to automate this thing. We didn't think through the licensing impact on that automation. So when it comes to cloud, for a lot of people, cloud is the first time you get penalized for being naive about how much your infrastructure costs. Like, if you're on-prem and you buy 100 servers over capacity, who cares? You cut that check once to HP or Dell, and then over time, you amortize the cost, and then no one complains, right? They paid it, they complain when they paid it, but at least the cost is somewhat fixed over a 5-year period, and it's okay. But in the cloud, if you start wasting compute, spinning things up, never shutting it down, getting no value, you're already paying a cost premium. And so it will punish you for abusing and being wasteful. And so I think when we talk about this specification, if you're Amazon, right, the first, in many people's eyes, the first full service major cloud provider, you're going to offer people billing through an API. And you're going to do what makes sense for Amazon, right? They have all these products and services. Some customers want granular billing. They want to know, how much am I paying for each IAM rule? Like, that's very granular. Like, that can get very complex in the data set for the financial output, because then it will take on the identity and shape of the thing that that's tracking for billing, right? We don't have barcodes and standards like you have in the grocery store. We're not at that level. And so Amazon is going to produce these reports that mimic the complexity of their platform. And then you get Azure and you get GCP, and they're all going to do what's right for their customer base, rightfully so. But just like the evolution of S3, this object store that Amazon provides, I watched when I joined GCP that they had to add an S3 compatible layer, because the community of customers are like, listen, we're not just using one of these. And if I have to write code for AWS S3 and for GCP object store, then this is going to be too much work on our part. And honestly, all we care about is the parts that S3 provides. So just give me a compatible API and you do the heavy lifting. So the FinOps community, I can see where they would say, listen, a lot of financial work is dealing with data forecasting, doing analysis on how much you're spending, and then figuring out where to cut spending. And you need data to do that. So it makes sense to me that we follow the same lead we did with Prometheus protocol, S3 object store, HTTP for people that want something more broad. And you just do the same thing and you look at this and say, okay, between the big three providers, remember startups like Cloudability have been doing this stuff for a very long time. Now it just makes sense that we just make it an industry standard. And one thing I'll say here is there's a lot of people who believe that every big company just has like a group of people behind the scenes playing Austin Powers, like malicious, lock you in to my billing data. I'm gonna be honest with you, no one is probably spending this much time figuring out how to lock you into their billing data schema and format. It's just not happening. Typically what happens is they build something that works just like you. They got something that people now depend on just like you, and they can't change it easily without breaking everything. So what they have to do is be very pragmatic. So when we talk about these initiatives where companies come together and say we're going to have a schema, think about the trade-offs that had to happen. Like, is this a mandatory field or is it an optional field? Right? We don't do granular billing, so how will we represent that kind of data? But this is the type of conversation that goes on behind the scenes, and we'll get there. We'll get this financial ops spec. It'll probably end up becoming the lowest common denominator. It's going to not represent everything. You know what's going to happen? You're going to get a nice base layer from this, but then when GCP or Amazon does millisecond billing at network packet level, it's not going to be in the spec for many years until that conversation happens. So what will they do? They will have to start doing extensions, right? There will be a new extension to the schema that only works for one provider. So I would say, but this is the natural course of evolving API-driven infrastructure. So this is just another great example of that.
Yeah, and we see that also, of course, between open source projects themselves. You mentioned Prometheus, but we saw things such as I don't know, in the monitoring space, you have the Influx ecosystem with its stack, and then you have the Prometheus stack, which are not aligned. Then you look at the logging again, just going to the observability because most of my audience, this is the sweet spot. And so many exactly, and OpenTelemetry trying to finally, after so many years, we've been doing logging for decades. And then from the 70s, I think I read an article talking about that. And only now we're finally talking as an industry, as a community, about how the semantic conventions, how the specification should look like for what is a structured log, ultimately. Not to mention across signals, to use the same common fields or labels, whatever you want to call them, to be able to correlate between signals. So we're finally reaching that point, and even that needs negotiation, even between open sources. So now we had the merge of Elastic Common Schema into OpenTelemetry because you don't want to conflicting or competing standards, because then no one will be standard ultimately. So this bringing together, and each one, as you said, has its own constraints, especially things that are tightly coupled with the backend, with storage. So many of these tools started by implementation that is very much reflective of how it's then stored in the time series database, for instance. Sorry, you wanted to say.
But it's very hard to innovate in the standards box. It's just hard. Like if you're really trying to build something innovative, something that serves the purpose for customers, it's hard to do that while you also have to gain consensus first. Like if Amazon had to get everybody else to agree on how S3 should work, you don't get S3. And so sometimes you kind of need a buffer of saying, we're going to have to go try things. We're going to have to be able to change things with only getting consensus from a very limited audience. I think Apple has this advantage, right? They got to make the M1 processor, M3 processor just for Apple. They don't have to go talk to every hardware vendor to see what their needs and concerns are. And I think it takes enough time of innovating, getting to a plateau where you say, all right, I think we've really have a strong checkpoint at this point. There's going to be only incremental change from here on out. Now we're ready to standardize. And honestly, I think that's just what you want. Because if you don't do that, you're going to get stagnation too early, right? Yeah. Where the standard prevents you from doing anything because it will break the standard.
Yeah, that's true. We have actually an interesting, we mentioned OpenTelemetry, and there's an interesting question here by Sean Pitts. Do you ever see an evolution of OpenTelemetry where a common schema is adopted and a unified UI across logs, traces, and metrics?
I mean, some people will argue that all of this stuff is just logs. Like all of it is just some log, and then how it's represented is what gives it this form, right? So what's a trace? right? A trace is like a log with some semantic meaning, and it's being produced by libraries at different checkpoints and is aggregated together and is visualized together. But then when you take a trace and you take the same trace ID and you put it in the log message, and so now you link the context. So does that log now become a part of the trace? Is it additional metadata that backs the trace? And then when we say metrics, okay, what is a metric? A metric for some people is a specialized log, right? This thing says someone hit this endpoint at this date and time, right? And then when you put it into data form and you send it across the wire, in that moment, is it just a log? And the way we interpret the log can be seen as a trace, a metric, or just a raw log file. So when we say structured logs, I think what we're saying is that we have a body of data that we're yet to classify. Because some people will do billing just on logs. Every time you do something on the website, it produces a log. Sometimes we call that log a message, and we put it in Kafka that appends it to a log. And there's this idea that the log is the database. So sometimes the way I look at this from a pragmatic standpoint, logs are unclassified data structures. Once you classify it, you turn it into a trace or you turn it into a metric. And I think what systems try to do now is just say, well, if you're going to make a metric, then we can delete the other context because maybe just the numbers in there already have meaning. So all you need is a label and some numbers, and then the system will extrapolate it. But you know what happens when you lose that kind of data? This is why I think you need all three, is when you lose that context and detail, then you got to make it up in the query. You ever seen some complicated Prometheus queries? It's like, oh, this data means this things. And when constructed this way, it takes on this new shape. So this is what this Grafana dashboard means. So I think it's one of these things where you need logs to give you context and shape. And then all the other things are metadata or forms of logs that are a little bit more specific, and you bind them back together. So can you have a common UI? So the part is around experience. Because what is the experience? For some people, they don't care about any three of these things. I only want to look at these things to tell me where I should optimize. Is the system slow? Well, traces can help you identify where the system started, all the levels it went through, and you have to determine whether that's good or bad in terms of latency. And then you should take action. So I think there's going to be room for UIs that say, don't worry about all of these logs and traces. We're going to give you a summary and say, hey, you need to set this config flag in Nginx. If you do this, latency will drop by 10%. That is better, in my opinion. That would be better than all three of these things. Now, the reason why we need all three of these things is because we don't have that. So I think this is what the AI community is moving towards. Like the folks at New Relic, right? They have this thing called Grok that tries to take all three of these things and just treat them as raw data. So when you come with a prompt, you say, what hard drive is about to fail? You need all three of these things to make that determination, because I can probably predict that, man, the same traffic goes through all three servers, but this one server is the slowest. And then you drop down to the logs. Oh, they're getting these kernel errors, or they're getting these file system errors. How long are these file systems errors are creating slow responses from the app server that's on it. That's the only reason why it's slow. So all the traces look the same, but you got to get to the kernel logs to see the difference. So you could say, we just want a UI that just munges all these things together, and then I'm still trying to find the needle in the haystack. Or some people say, give me a prompt so I can just say, what is the slowest hard drive in the cluster? That's a whole different UI. So that's why I don't think we want a unified UI. We want structured data so then people can experiment with the UIs. And then depending on what you're trying to do, if you're doing needle in the haystack, then you probably want to see a lot more raw data and just write queries. But if you're someone that's like just on call and you already have a good model of what healthy looks like, you just want to ask the model, quote unquote ML or AI, hey, given all the data that's flowing through the system and the model we created for predicting errors, could you just tell me what hard drive is bad so I can just replace it really quickly? So I think the answer is no for the sake of innovation.
Interesting. First of all, you already started touching about where you see the industry heading next with AI, and we talked about it. Actually, I heard from people that attended the KubeCon that you gave a very interesting, insightful talk on the executive summit about where you see AI. And I hear lots of buzz, to be honest, about AI. To be honest, also wearing my vendor hat at Logs.io, we are also experimenting with the AI ourselves, including generative AI and language models, and doing a natural language query that then translates to Lucene or whatnot. So it's there. However, I think that we're still quite some time, a few years from getting to the point where we can actually discard the UI that you consider manual, that you need to dig into different visualizations to do the root cause analysis, and instead doing some natural language type of questions to do the digging. So I do think that we still need, as an industry, to think about the midterm of how we address the UI. And actually, there is a gap. We've been doing a lot of advancement in the ingestion part, and also in the storage part to a large extent. I think the UI is the least advanced. We're still, either locked into a specific UI approach by Grafana or by other tool or something like that. But there is no common language. There is not even a language that lends itself to GitOps friendly automation, CI/CD, and things like that. So we can't really now make it part of our regular drops, like we drop the application. I would envision that as you drop the application, you drop a visualization dashboard that goes hand in hand, coupled in the same namespace, in the same context as the application, and also evolves with the versioning along with the application. We're not there. So that's on the midterm. I think as an industry now, the question is, and everyone is asking that question and explores, where we can actually put the AI in practical measures beyond the hype to actually help us dig and get these insights out of the raw telemetry, which is interesting.
So I think AI becomes a distraction. So this UI already exists within people, right? Some people can look at a dashboard and say, I know what's wrong. Nginx is broken. Like, how can you tell just by looking at these 5 dashboards? It's like, because like this red thing over here means this. We've seen it before. My guess is there's a soccer game going on. We have a big campaign that's running. We're getting 3x more traffic than last time. I know the config because I wrote the config. And I was debating whether I should use this option or not. I was debating, should I put it on a bigger server or not? And I chose to make a trade-off. So seeing these graphs lets me know my trade-off is wrong for this situation. That person is walking around with this very refined domain-specific model in their brain. And so they just can glance and say, I know what I'm going to do. I'm just going to increase the instance size of the Nginx instance and watch what happens. As soon as they do that, all the graphs relax. And then you look at this person like, wow, man, this guy is really good. This go-to person is great. And so now what vendors are realizing is that for the average person to do that is hard. So right now, the best we've done is giving people click ops, drag, drop, sometimes you have a custom query language, you have to write this cool expression and you have to know so much about the data schema to even craft such a thing. And then you can turn that into a visualization. So you got a little chart. No one knows what the X or Y axis means. They're just like up and down or green or red is good or bad. And so this is the status quo. So when I hear LLM, is a very limited scope of AI ML, which says, let's try to use natural language to give a better query language. I don't want to write PromQL. I just want to say something like, how many HTTP requests are we getting for the credit card service? That's all I want to. I don't want to try to do this percentage summarization. It's like, come on, I don't know that language. I just know what I asked for. So today we're asking people to take what's in their mind, natural language, and translate it into this weird schema, generic programming language where these two things don't match. And I have to just make it work through brute force. So I think on one hand, we're saying, let's get these systems closer to the way humans actually think so we can take our thought and give it to the system and you give me results without me having to be a translator. But also on the other side is, and I agree with you, we're early on. I think the future is that people want these hyper domain specific models that they can apply to data, just like the example I gave of someone with a lot of experience and context can walk up and then do something. And I think that's where we're going to have to find, we're going to go back and you know how people used to write bash scripts that were really good for just their needs? These were not Puppet, Chef, and Ansible. These were just like, no, man, all we need is like 50-line shell script and it does everything we need. I think a lot of the ML domain stuff that we're talking about is going to be the equivalent of creating a model that is hyper specific for your situation and is useless to the next person because they don't have your same domain or context. And I think that what I mean by the future is like going back to the way humans already work, but just teaching our systems to allow that level of customization. That out is what I think. So we need this step, which is we got to structure all the things. We got to get the data aggregated. We got to give it shape. We got to give them labels. So that way, once we have it, then this style of programming, AKA ML, AI, can work because now we have enough data to use to even make these models work and do the same training that we've been giving our SREs for the last decade.
Yeah. Makes sense. I just think that there's a lot of hype, and we need to look at it more in a clearer view. And I think you bring lots of sanity into this in what you said. So, and talking about going back to your baby, you've seen that in the last decade, the Kubernetes and where it headed. And last month at KubeCon, there was a keynote by Tim Hawken about what the next 10 years hold for Kubernetes. I watched the keynote from afar. Unfortunately, I wasn't able to attend in person. I had my thoughts about this talk, but actually I was curious to get, as someone who has seen it from birth, where do you see Kubernetes heading in the next 5-10 years? Maybe the main challenges and the main opportunities for Kubernetes to evolve.
I mean, my guess and approximation is based on the trajectory of Linux. Linux is 30 years old. It looks very familiar to when I started 20 plus years ago. It looks very familiar. It has a shell. A lot of people interface with it through SSH and some terminal. That's most people's UX to Linux hasn't changed in a long time because it can't, not easily. Now, that doesn't mean that you can't embed Linux somewhere else, aka Android, right? So there's people with a bunch of mobile phones and their interface to Linux is very different than the system administrators, use in Linux. So if you look at Linux from that, or you look at Kubernetes from that lens, it can both be a straight up front end. So a lot of people will continue using the Kubernetes model where we take something people want to do and we make a new API structure for it and we call it a CRD. Great. That's universal. It's like REST. RESTful interfaces are around for a long time. And then the thing you will be able to do in the future is just get rid of the implementation. So you can do HTTP with Envoy, Nginx, Apache, Apigee, Amazon Global Load Balancer. It doesn't matter now because now the protocol has transcended the implementation. And we're going to get to a point over time where Kubernetes implementations will transcend. Like Cloud Run, there is no Kubernetes in Cloud Run, but it has a Kubernetes style API, but no Kubernetes. So we already see this in motion. And so now that I think Kubernetes has been done for some time. So the Kubernetes that we're talking about is the thing where you describe a pod and health checks, storage requirements, and there's this core set of objects. And that's the promise the community has. We have CRD, so you can extend it, have emission controllers, and we have these things. And then the API now has versions, so you can decide as a community how the API should evolve. But you all know you can't change it fast anymore. You cannot just overhaul pods. Sometimes you're going to have to just make a new thing like Gateway API to complement services or ingress. That's just where we are. And I think that will be the new pace of evolution. Now the hard part that's hard to swallow is like, what happens when people don't care about it anymore, right? Then you can get pushed down the stack. And when you get pushed down the stack, you're still important. You're just less visible. So no more KubeCon, no more fanatics. No one cares anymore about how it's evolving except for the people working on the core. And then the people that come in later. You know how many people that only know Kubernetes but don't know Linux? That number is growing. And so there's a chance that people will want workload specific platforms. So Kubernetes is kind of a generic platform. It's pretty powerful. But some people are going to want something that's just for batch jobs, just for machine learning workloads like Flight that layers on top of Kube and turns it into an end-to-end ML platform. Cloud Run turns it into more of a PaaS or a serverless platform. And so I think you're going to get more and more of that. And so once you get more and more of that, then Kubernetes starts to shrink because it did a good job and it deserves to be a foundational component. And it just has to be sturdy and strong. And then you'll have more people saying, do we need to put it in core or can it live outside of core? And I think CRDs did that. No more evolving the pod or the deployment. Just do CRD if you want something more specific. And then Argo CD is born. And Argo CD is more of a, in many ways, Argo CD is a better jobs API, right? You can do way more stuff than trying to make jobs do all of that work. So I think Kubernetes did a good job. It brought people onto this idea of structured infrastructure. it gave an API and an SDK to this wild west of config management and random tools, and gave people an option to work in a different way. So that's where I think Kubernetes is. But I think one thing that will stick around, though, is this idea that we can formalize what a declarative API looks and feels like, separating the control loop, the implementation of the CRD from each other, and so that they could be replaceable, they could be composable. So on the front end, you can now build data pipelines. I like this phrase, infrastructure as data. No more writing all of this kind of code to do stuff. You can do it and just put it in the control loop, but on the front end, it can be data. So then we can get voice APIs, we can get a web UI, we can get things like KSonnet, we can get things like, what is this thing? I keep forgetting the name of it, but it's a declarative way of actually composing Kubernetes manifests together. It's actually baked into kubectl at this point, customized. That's what I was looking for. So now that we have infrastructure as data, I think that's going to open up a whole new set of UX and UI for doing this. GitOps is one of those experiences that you can put it on top of this model. So that's what I think about Kubernetes. It's kind of done. It's going to evolve a little slower, and it's going to earn its position as a stable infrastructure at the bottom. And I think we got to be okay with that if Linux is any guidance on how this will play out.
Actually, in a way, it's what happened. We saw it with containers. The container runtime started obviously with Docker that popularized the LXC and all of the capabilities within the Linux kernel. But then, there are lots of excitement about Docker, knowing Docker. But then at some point, it became a commodity, as you said, and Kubernetes actually pushed Docker and later on other container runtime alternatives down and created another layer, more elaborate one on top of that. So in a way, you're saying what Kubernetes is done to Docker and other container runtimes will be done to Kubernetes itself eventually once it's a stable layer.
And the way I look at it is, if that doesn't happen, if 20 years from now we're still talking about Kubernetes as like the front end of what we do, that means no progress happened. Right? So I guess it's a benefit to those that bet all in. I know there's people with Kubernetes tattoos and they're all in, but think about a world where we're still doing Linux right now as the number one best we know how to do. That means we didn't learn anything above that. So I think if you're being honest and you really want the same evolution that brought us to Kubernetes, you should probably still want the same evolution that makes Kubernetes disappear.
Yeah, although you mentioned Kubernetes in many types of use cases. You gave the example from the equivalent from Linux, where you have the Android and you have obviously the servers in the data center, all the range. And in Kubernetes, there are lots of talks about edge cases and IoT, and then obviously the classic backend. But then you mentioned also, for example, AI workloads running on Kubernetes. And I'm wondering if we're not trying to take Kubernetes to too many areas and not looking at where it actually benefits us, because AI is a good example where maybe a title coupling, actually, the Kubernetes provides us decoupling of the infrastructure from the applications that consume the resources. In a way, what we see in the industry is actually specialization when it comes to AI. You have specialized chips, CPUs, and specialized hardware to make the most, because this is a very consuming and demanding workloads, both in the training and then in the inference of the models in production to do it at scale in real time scenarios. Actually, you write something in your search and you get as you said, the insight, for example, but you don't have to wait for 5 minutes for that to crunch the thing. So the question is, if we're not expecting too much or maybe losing sight of where Kubernetes brings the value and not forcing use cases like AI where it might not be a good fit.
Well, so just think about like an AI workload. So a lot of AI is prepping the data, right? You have some data. It can be in an S3 bucket, and I need to run compute over the data to get it into the right shape. You just don't drop random images into a image model or classifier. The images need to be in the right shape. So we're going to reuse some data processing techniques, right? Taking the images, resize them, or toss the ones that are garbage. Okay, so you can run a container that talks to an S3 bucket and transforms it and outputs the results back to S3. Okay, this is generic. So then the other thing is we want to train the model, right? So that means we need compute. So yes, we need more than just CPUs. We need accelerators. NVIDIA is a very popular accelerator. So now we get into the idea of orchestration. I have to get this workload packaged. Why not put it in a container? I need CUDA. So package all the things you need. And then I need to assign this workload to a machine that has the right accelerators. So that means I need to classify my machines. So if you look at Kubernetes as it stands today, it's pretty generic. You have a node object, and you can put as many annotations as you want to say, hey, this thing has a NVIDIA 100 HT. Great. It also has a TPU attached to it. Great. So now maybe the current scheduler isn't smart enough to know how to really optimize that, but you can do it. You can make a scheduler that is dedicated for understanding how to utilize that hardware efficiently. So then you have front-end frameworks like TensorFlow. All of these frameworks, guess what they do? They take in your training stuff and turn it into a schedulable object and job that can be scheduled in parallel. So it's going to take your front end and say, okay, I need this many binaries or containers to run across 50,000 nodes, but those nodes must have these things. So then the front end scheduler works with the back end scheduler to do this matchmaking. And then you need job control. So if you don't have Kubernetes and you want this, then you have to invent orchestration. Like, you just got to invent it. Like you can't just take a bunch of VMs and then do what? Run a bunch of shell scripts? Like, you're going to invent Kubernetes. So this is where Kubernetes finds its sweet spot. It's good enough for common scheduling needs, but you can just also just put in a scheduler name in your workload to say, don't touch this. Don't touch this workload, Kubernetes, because you're not smart enough to schedule this. I need the NVIDIA scheduler. And the NVIDIA scheduler can jump in. So this is what some of these frameworks are actually doing. So Kubernetes in many ways is too generic to replace something like Cloud Foundry if you like that, or Heroku if you like that. And then it has just enough, but not enough to give you a full ML platform. So just like Linux isn't enough for building a full distributed system, you got to layer something on top. I think what Kubernetes is doing is leaving room for these platforms to say, hey, you have enough SDK components for the common needs that I can just layer on top and do all the missing parts. So in many ways, some people wish that Kubernetes would do stuff in the core to make it more appropriate for edge or ML workloads, but it's like, we shouldn't. We should just draw a line that we think these are common needs where we're missing, they can be pluggable, and then you have to add in the next layer without having to rebuild this layer first. So in many ways, I think it's kind of appropriate to allow frameworks to be built on top of frameworks. Like Vercel, some people look at it as just like some skin on top of the React model. But it's like, but that's great, because then Vercel and Next.js gets to focus on experience and giving people better tools to build amazing UIs, not trying to figure out should they use the React model or this model. So I don't know. I think it's just kind of an evolutionary thing. But maybe to your point, one day someone will say, this is too many layers. It's causing problems. And then someone's going to come around and collapse the layers and say, hey, we have a Kubernetes-like thing, but it's only for AI ML, and it's 10 times faster, more efficient, and you will never get this way by just gluing together a bunch of parts. In many ways, this is what Kubernetes was saying to the Docker community. You all are trying to glue together Nomad, Docker, Vault, all of these independent APIs, and then trying to glue them back together. Kubernetes is like, what if we unify them all to something purpose-built for running applications in containers? And then maybe someone comes and does the same thing for these other workloads. But it's so nice to have this as a starting point so we can figure that out without inventing this layer over and over again.
Interesting. So, because there's a trade-off here between supporting specialized workloads and the use cases, and squeeze more out of the machine, I guess, versus adding APIs that everyone can see, and there's also impact obviously on stability, reliability, security. We talked a bit before about having Kubernetes as a robust thing with some guarantees that organizations can bank on for enterprise grade, or if you'd like to call it that way. So I guess there's a balance to strike here in that respect as well. But
some people in the AI world say we just need a new computer. Like, the current computer architecture is a waste of time. This thing where we have a bunch of pizza boxes connected by Ethernet cables is not appropriate for what we want to do. And so I think some of these super machines are saying eliminate the need for Kubernetes style working altogether. And some people are saying maybe the mainframe way was right. Have a bunch of specialized hardware highly connected by high speed things, not Ethernet. And then we get this box that is so optimized for the situation at hand, you can eliminate a bunch of other software. Yeah. And so Kubernetes is going to have to compete with that world. And that world may show up and we may say, man, no one does it that way anymore. We don't need orchestrators and gluing together APIs. And look, if that yields results, then we need to be prepared for specialized machines that delete the need for all of this additional software.
Yeah, makes sense. And zooming out from Kubernetes to the CNCF, the Cloud Native Computing Foundation, you look at we talked about the complexity of perceived complexity of Kubernetes, and then there's also the overall landscape. And I hear that day in and day out from users that meet the landscape for the first time, the hundreds of projects and options, and are not sure how to approach that. Too much choice in a ways could be, I guess, baffling, paralyzing. And I'm wondering again. You've seen the CNCF since its birth and its inception. How do you view the way that the CNCF stack and ecosystem is heading, and where do you see it going forward?
I think people are, and maybe rightfully so, I think people are confusing choice and transparency for complexity. Like if you buy a watch and you can't see inside of it, you think it's probably simple. Like this is a simple watch. But if I showed you something where you see all the rotary dials moving, you'd be like, that thing's super complex. Look at all the little gears in there. That's crazy. It's insane. It's too complex. But you don't say the same thing for the one you can't see inside of. You're just like, oh, it's just simple. So Heroku seems easy, right? You just do push and then your app is running. I guarantee you the inside of Heroku is so complex, you can't run it on your own hardware. And so when it comes to Kubernetes, you get to see all the parts. And it might be that Kubernetes is actually a simpler design. I tell you, it's definitely simpler than Cloud Run. It's probably simpler than Lambda is. Probably guaranteed simpler. So when you look at Kubernetes, it's like, oh, it's too complex, just use Lambda. And what you're saying is that using Lambda is much easier than probably running Lambda. So you're not really comparing the same thing. And so when I ask people, it's like I said, what would be easier? They said, oh, I can just use a VM. So when you say just use a VM, think through this for a second. Let's just say you have to set up a situation so people could just use a VM. Let's just be honest. Now, if you're using the cloud, then you also are not talking about managing the hypervisor. In Kubernetes world, you are managing the cluster if you just go to GitHub and download the bits. But if you were to do it from scratch, for people that don't know, you got to get hardware. You got to rack and plug it in. Some people don't even know how to deal with power. Like DC power is different than AC power. Some of these power supplies are very different. There's power conditioning. There's backup batteries. Some people know nothing about the power, let alone the cooling. So let's say you get power and cooling. Now you got this thing racked up. How is it going to get an IP address? Are you going to do DHCP? Have you ever set up a DHCP server? Do you know you got to get the MAC address so that the machine gets the same IP every time? Are you going to put that in your DHCP config? Okay, some people don't even know how to do. Then how are you going to provision it? Most of these aren't sold with a CD-ROM. Oh, you don't know anything about Pixie? You don't know how to load OS image and get a Pixie server? And so this is hard. Most people have never set up a Pixie server before in their lives. This is insanely complex. We haven't even gotten to the part where you got to configure the OS at runtime. Are you going to do pre-seed or kickstart? People have no experience with any of this. And then we're going to do all that so then we can pick a hypervisor. You want to do VMware? You got storage? You got VLANs? You don't know what a VLAN is, right? You don't know what a leaf and spine is. So there's so much complexity that goes so you can just get a VM. But here's the funny part. Once you do all of that and you have a VM, then what? You're going to put Puppet, Chef, or Ansible. Are you going to use Terraform to create the VM? Are you going to connect it to this VLAN or that VLAN? Should it mount storage? Or are you going to use NFS or iSCSI? There's a lot that goes into this decision. And even if you do all of that, you still don't have a container image. You still don't have service discovery to connect to the F5 load balancer. You don't have any. So you're going to go build all of that. So when you have Kubernetes, what are we talking about? We're talking about someone making all of these decisions for you and saying, create a YAML file, kubectl apply, kube service expose, and all the things I just talked about get set up. So Kubernetes assumes you have IaaS underneath. Now, running Kubernetes yourself is very different than using something like GKE or AKS from Azure. It's very different than using something like Autopilot, where now you get on the same level playing field. Like if you like EC2, just the VM, then the corollary to that would be autopilot, where you cannot even create the cluster. You don't make cluster. You just give it workloads. So I think people just really got to compare things at the same level. And look, maybe you don't really need Kubernetes. You just want to run Jira, one VM will do. Great, do that. But don't discount the level of complexity when you need to run Jira as a service like Atlassian does. And you need orchestration and scheduling and service discovery and load balancing. Then you have to ask that question, do I build it from scratch? Or do I set the industry standard to avoid or deal with that complexity somewhere? So I guess what I'm saying is there is a minimal amount of complexity for all of these systems. You just got to choose how you want to interact with that complexity. You can use a managed service if you want. You can make a trade-off on your app side to use something a little simpler for you, but harder for the provider. But there's a total level of complexity that you just can't eliminate by avoiding one system or another.
Yeah, that's true. Obviously, the comparing VMs with I guess Kubernetes still, you assume that there is some sort of a underlying infrastructure. You don't rack the servers and take care of the power and cooling and the assignment of MAC addresses. But I do think that, as you said, you have like an implicit load balancer that Kubernetes provides that you will need to set something up. I don't know, Nginx or something instead of that if you run your own VMs or something. We need to definitely see that. On the other end, there is a question about the level of abstraction. For example, one of the conversations that was interesting at KubeCon was whether clusters, for example, is an effective abstraction, if it's not something that is limiting in a way to many organizations these days. And I heard some of the fellow maintainers of yours there in Kubernetes project talking about like needing to work at a higher level abstraction as part of Kubernetes itself, especially with many organizations working multi-cluster. So I'm wondering still, and this is apparently a discussion also within the maintainer team, whether some of these abstractions are now becoming a limiting factor.
I mean, all of them are, right? Linux itself and its syscall interface is a limiting abstraction. You can only do so much with namespaces and C groups. And then you move up the stack. And the reason why we have nodes is because Kubernetes will scale down to run on your Raspberry Pis. So you have to tell the scheduler what the node does. So we have to have the ability to articulate the node and its capabilities. And then we need somewhere to report node health because you are abstracting over the top of a node. There's no magical machine. You can kind of create one. But for most of us, apps run on kernels that need memory, CPU, and storage. This is just reality of how your language runtime works. Your language runtime works on top of typically kernels. So you can try to hide it if you want. And we know what happens when you hide things that are really there. The moment you get a real error like out of inodes, you're like, why is my library saying out of inodes? Oh, there's a kernel that runs on a node that has a disk in it that's out of inodes. I need to fix it. So all abstractions leak in some way. These are all good things. I think they're nice problems to solve. But I do think anyone that has to manage this stuff for real, like if you're a platform engineer and you got to manage the cluster, yes, you should try to build something that hides as much as this stuff. But when you start getting these weird errors, you better pray that you can actually log into a machine and address the error versus saying, there's nothing we can do about it. That's not acceptable. So Kubernetes scales down and it's right for abstraction above it. And there will be more abstraction above that and more above that. And then we'll reset it all by collapsing the layers and then do it all again and then collapse the layers. We're going to do that for another 2,000 years probably.
Yeah, makes sense. I want to ask you another question from the observability side. So we've been in this show for, I guess, 4 years already, debating various aspects of observability, from the fine-tuning of exactly how you represent it in storage and visualization and different projects to higher level concerns. But I'm wondering, with your perspective, looking forward, how do you see us as an industry, as a community, evolving? Where are we taking observability? You touched upon it a bit with AI, but beyond being able to do that via AI, do you see any other directions where you think we should be striving as a community?
Why are we observing? I think a lot of people are just doing this stuff just out of muscle memory. Put agents on the server, put agents in our libraries, use Prometheus, collect a bunch of data, bunch of noise, push it somewhere. And then Maybe we set some SLAs around it. Maybe if something goes wrong, we try to peel through the noise and find the thing that will tell us where we should go look next or what to actually do. That's why are we observing? And so when you ask that question, like in a car, what are you observing? I want to know how fast I'm going. So we get a speedometer. We don't have a stream of metrics that's giving us speed per millisecond. Who's doing? Why would you want that? You don't have Grafana in your car. Just look at the speed dashboard. It doesn't make any sense because in the car is very specific. What are you observing? I need to see the tire pressure. I don't need to see the tire pressure until there's a problem with the tire pressure. So do not waste my time showing me a bunch of graphs about tire pressure. I don't care. The SLA for tire pressure is what the manufacturer suggests to get the best gas mileage or for safety, right? That's what you're doing. And so when that threshold, since we know what it is because it's been rigorously tested and engineered together, so when the tire pressure doesn't match the experience that I've been promising you, then I make an alert and I tell you the right tire pressure is not correct. And then you go and address that. See? So why are you observing? So the future is going to be, hopefully, we can start to answer, why are you observing? And give people the right UI that makes sense. So for the person driving in the car, I'm observing my speed because I don't want to get a speeding ticket. And so I can adjust in real time based on what this thing is doing. Or I can just use cruise control that's going to lock in where I set my SLA. Hey, 50 miles an hour, no faster, no slower. And then the machine does its own thing. I don't need to see the speedometer anymore. We just locked in on 50. That is the ultimate pinnacle North Star of systems using observability because it's only there to drive behavior. We're not observing just to be like, man, look at all the numbers. That's insane. So we observe for a purpose. So I think where we're going is more systems will get closer to the reason why we observe, and that will be the new UI. So instead of like, for example, in GCP, you say, I have this much money to spend, and I just want to make sure all my requests are served fast. Great. So we just give you one dial. And then under the hood, we use a lot of observability to see, are we giving you that or not? And if we're not, then we have to either add more instances or remove more instances. That's it. And so I think that's where this thing will end up going. So this input stream, right now, we're kind of in the Stone Age in this world where we just all look at dashboards and try to figure out what to do. But you've seen good systems where they take that as their own feedback loop and they just start adjusting themselves, right? It's like, wow, this is really cool, right? Things are slow, so we should cache more of this data. Like some databases that do this, they trade what data is in hot memory versus what's coming from disk in response to the queries. Now, you could do the other way and just do observability. What queries are slow, and then go back and type commands and say, all right, cache this. All right, now cache that. For what? Push that to where it belongs. So this will happen. Guaranteed. Now, I think software is a little bit more immature because we let people do anything without specification. A lot of us are managing apps that we don't know how they work or how they behave, so we're all just guessing. So to enable all these guessing and random behavior, we need to just watch. Like a security camera watching a crowd. We don't know what anyone's going to do, but we know they're capable of doing anything, so we just watch. And we can't really predict what you're going to do, so we just have to wait until you do it, and then we come and get you. That's kind of what we're doing now when it comes to like software systems and observability. It's so random. But I do think it's going to get a little bit better as the platform and the intention get closer. Then we're going to be doing something that's going to be way more actionable and way more clear about what it means.
Yeah, and, but to be fair with the comparison, cars are like what we used to have in systems in 10, 20 years ago when there was a finite number of failure states that people then designed dashboards and alerts to these specific sets. I think we're now in a much more Wild West in that case, that you're open-ended. This is what gave birth to the unknown unknowns, as it's popularly known. Because you don't really know. So you can't put a set of gauges that monitor a very finite state. We need to be, my view at least, of course, is that we need to look at it more as a data analytics problem, think like data analysts and be able to ask questions as they come along, things that we haven't anticipated in advance. So this is, I think, the challenge that we're facing with today's systems that are farther away from the car, from the closed system, finite state, very clear specifications about what's the, as you said, the normal state of the wheel. I don't think that the software.
Every developer is attempting to build a finite state machine. Every security engineer hopes that they have a finite state machine. If you do not, you will be hacked, you will lose all your data when your system starts doing things it shouldn't do. So we're all working towards building a machine with predictable behavior. The fact that we don't have that leads to all this security stuff and patches, wild vulnerabilities. We don't know what our dependencies are. In some ways, software engineering is sloppy. It's sloppy. Oh, I don't know who wrote this code. Just import it because I need this one function. And we say, no problem. We'll just observe it to see if it does something weird because we don't know what it's supposed to do. What? Yeah. So, hey, what are we eating? You know what? We're using a new chemical in this. We don't know what it does to people. So you have to eat it here so we can watch you. Also, when you eat this dish, you have to be hooked up to a machine that's checking for your vital signs because you could die. So we want to know, will this kill you today? So we're going to watch. No, I need you to know what's inside of this food, right? I need someone to make sure. So I'm not saying we have that already. I'm saying it's a byproduct because we don't have it, that we're compensating with extreme amounts of over-engineering, with extreme amounts of waste, because we've allowed this to happen too long. So when people say the software engineering world needs to mature, it needs to mature drastically. So this is why some people are saying you can't do ML with generic CPUs because it's not efficient. This is why we have accelerators that are purpose-built for this situation so we can actually do it much better. So they're starting to mature in that field of domain. So some people, I think the Wiseman people are trying to tackle this, saying, hey, why are we building you can do anything software? Let's build software that has a target with very few system calls, very few behaviors. Some people in the functional programming world also believe this, right? Limit the side effects. So when you eliminate the side effects as much as you can, I get it, we have CPUs and time is a thing, all this, but what you're trying to build above that is a predictable system. That once you can have a predictable system, then the way we observe its behavior is better. You're right, you will always have the just in case type of observability, but that should be for the because every car I know still has a diagnostic port. So when things are off, that means there's some calibration off in the system or a sensor could be malfunctioning. There's also that, but that's why we have that diagnostic port where you can get the raw data to really troubleshoot things. But for the day-to-day, since it is a finite state machine, we only need certain high-level dashboards in our face at all times, and we special case the other stuff. Today, I think people are just like, see all the things because we just don't know, and it's hard for teams to special case or to be very precise in what they predict.
Amen. I wish we see that soon. I've been in the industry for 25 years as a programmer and stuff, and it doesn't feel that we're maturing in that direction. But really hope to see that. That's a
I want to say this though: there are people who probably are. It's just not sexy. People will see these mature things like, oh, that's boring. You don't have no outage. There's no firefighting. You're not using 7,000 tools. So those people don't get invited to talk at a conference. Like the title of this talk is Everything is Working. Oh, man, that's boring, bro. Like, I don't want to make the same decisions you made, even if it will lead to everything working. That's just kind of human behavior. We like excitement. Hey, this thing goes down all the time. Here's how we deal with it. Ooh, I love this.
And I delivered my software with a clear specification how it's supposed to be working and what are the CPU amount that it needs to consume normally and things like that. Are you serious, man? Is that software? No, you're a bureaucratic guy. So yeah, that's.
Or you're my airplane. That's why I fly on certain airlines and not others.
Yeah. So just before we wrap up, what's since you retired officially from Google and now you're exploring new avenues, what are we expecting? Where we're expecting to see you and hear from you in 2024 for our audience to follow up?
I'm everywhere. I go where I need to be. That's it. There's no like high level plan, but I do spend a lot of time still working with startups. So behind the scenes, a lot of the favorite open source projects, I'm there helping shape where they go, getting these ideas, this experience into the product, learning as much as I can. So you'll see a lot of that in 2024. I'll continue working behind the scenes. And also I'll still do these Twitter spaces and live streams because these questions are how I also learn. The feedback that we get is how I also learn. So I think I'll still continue to participate in the community. So I'm not retired from the community. I'm just retired from corporate America.
Well, I'm looking forward to keep on following you and getting your insights there. So thanks a lot for helping all of us. getting a clear path there. And thank you for taking the time to join me on this show. It was amazing.
Awesome. Thanks for having me.
And I want to thank all of our audience for joining us on this year-end episode. As everywhere, you can find all the episodes on your favorite podcast apps or on YouTube. This episode, and if you do listen to that on demand on the podcast on YouTube, do know that we live stream the episode. So do follow us on Twitter at OpenObserve for updates on the live stream dates and to share your comments, suggestions, news bits, and everything else. And I'm Dotan Horvitz. Thank you very much for listening, and see you on next month's episode. And as always, may this open source be with you.